Okay. See, a few more interview questions on the SQL. See, everybody will get like the question like if you are attending like interviews on the SQL. See, the people will ask you what is join, what type of joins we have. Okay. See, join is a condition which is used to retrieve the data from the table, from the table, one or more than one table. So you no need, okay, see, while retrieving the data from more than one table, see, now you are in the table, let's start from EMP. So you are retrieving this data, right? Now you are not using any condition here, simply you are getting the data. Okay, so now go with create table, table A, and C is the column for that. Number is the data type of that. And B is the table I'm going to maintain it. And I'm inserting the data into this. Insert into the table A, setting the values which we have already in the list. Okay, so then you can get to know 1 1 null, also 1 1 2 this, right? Copy if you can able to copy the data, so you can try to. Okay, so you inserted the data one, it missed the values keyword here, values. Okay, it got inserted 1 1 2 3 and 3. Inserted in null. Okay, you can check this data is present, what the data we have in EMP, sorry, table A. 1 1 2 3 3 null. Now I am trying to insert the another table values in table B. Okay, so now I am trying to table B have one, have two times, and we have the three also two times, and null two times. We have 4 5 5 4 5 5. So totally I record all the information. You can check in this table B as well. And now we have this data. Now we want to retrieve the data from both. See, now you are retrieving the data with one table. You no need to put any conditions here because you are retrieving only one table of data. Now we are trying to retrieve the data from both, like more than one table. Okay. So now I'm mentioning simply, okay, see table A and table B. See, now you are trying to retrieve the data. See how many records I'm getting in this case. 60 records. See, my table A is having how many and table B is having how many records. You can verify it once. So table A is having 6 rows and table B is having 10 rows. So you are getting like a 10 into 6, 60 rows. If you know the matrix multiplication, so the matrix multiplication will happen in this way. Not in this, actually, I'm going to find. Okay, see, if it is the matrix 1 and matrix 2, if you have, the multiplication can happen in this way. 1, 2, 3, 4. If we have this 2 by 2 matrix and come to this place, it happen like 6, 7, 8, and 9, 9, 0. So if you have a 2 by 2 matrix and a 6, 3 by 2 matrix, okay. So in this case, if you have, right, so the matrix, if you did the matrix multiplication, see, the first matrix of each element is going to multiply with the other corresponding of other matrix of each element. So 1 into 6, 1 into 7, 1 into 8, 1 into 9, 1 into 9, 1 into 2. In this way, every element is going to match with or multiply with each element of the corresponding matrix. The same thing is happening here. So I'm taking the one record from this particular table. I'm taking this one is trying to match with every record. So one is going to match with the one into one, one, two, one into two, one into two, one into three, like this. It happened with the 10 times every element, right? Now, now I'm trying to retrieve the data. So if you haven't mentioned in the sense, it's a cross beta, cross multiplication. So then, so how you can compare? See, now you are using the joins here. So now I'm using the join mechanism. Simply table A dot C equals to table B dot C. See, now I'm getting with only 8 records because see, we have the variety of joins here. We have so different types of joins here. Inner join. The inner join or simple join, both will be same. Inner join is used to get the matching records from both tables. So while retrieving of the data from both tables, it look the value. One is present in this displays. One is present in this displays. And two is also present in this. And the two is going to match with two times. For this two is the second record and third record, both are the two values. So this two is going to match with two times. So the two will be displayed two times. And three, this three is going to match with one time. And this is for the fifth record. So again, this three came here and you are going to match with two times. Okay. So you will compare for every record with all the records of the corresponding table. What are the matching records we have? One equal to one, true. One equal to one. Sorry, one equal to two, one equal to two. These are all false. Then came to the second record, one equal to one, true. It displays again one, one, two times because one is having the two entries in this and two is matching with this, again matching with this. So it displays two times. Okay, you need to be aware if you have the duplicates in the both tables or single tables. So did the multiplication, how many times it will get? If you have the two in corresponding table having one in the sense, you will get two times. If the corresponding table is having three and another table is having four in the sense, you will get 4 by 3 because of these duplicates. Because of these duplicates. Now, now see, if we use the inner join, I'm saying it get the matching record count as 8. See, the same thing is getting in this place. 8 records, one into one, one in. This is the output for this. See, we have other joins. We have other joins. The other joins will help us to see you are able to get the matching records. See, who are not matching with the corresponding table, that you need to know. That you need to know. So meaning you need to retrieve like a non-matching records as well. Non-matching records as well. See, for that we need to use the outer joins. See, outer joins to get the matching information along with the non-matching information. See, in we'll use the outer joins. In outer joins, again we have the three types: a left outer join, and right outer join, full outer join. See, if we use the left outer join, we get all records from the left side table and matching records from the right side table. The matching, this is the, if you mention like a left table A, left join with table B, then this is your left join. This is your right join, right table. Okay, if I use this left join, simply this is the old method, ANSI method, hash join and hash method and ANSI method. Two things we have. This is the old method which we are using. Simply, you can go with the inner join. So instead of where class, you need to use on class. So this is our inner join. You will get this. Simply use a table A left outer join. You will get the left side full information. And see, if we use any outer join, the inner join results will be same. The 8 records will be same. You are going to get additionally the non-matching records from the left side table. See, what the record we have at the non-matching side, we have only null is the extra record here. So you are going to that as a 9 records here. So I already mentioned in this count as well here. 9. And another thing, if you go with right outer join, see, if you go with right outer join, you may see some extra records. 8 plus this null is the 2 times because null is not equal to the null. In the joining perspective, null, if you compare, null is equal to null. It's a false. So this null is value the different, this is the different. So you will get the 2 null records here and 4, 5, 5. So totally we will get 5 extra records other than the 8 plus 5. You will get 13 records. You can verify it. So right outer join, simply 13 records. And in case if you go with full outer join, the full outer join will help us to get the matching records and non-matching records from both tables. See, earlier you got like 8 for inner join, left join you got 1 extra record, and right join you got 5 extra records. So totally 8 plus 1 plus 5, 16 records. Sorry, 14 records. This is what you got here. So this is about the joins. And we have, is there any other joins? Yes, we have the other joins, the Cartesian product. The Cartesian join or cross join is a join. If you haven't mentioned any join condition, it will go for the Cartesian join. Yeah. And we have other joins, self join. See, if you are joining the table itself one more time, that with the same table you are joining with one more time, that we can call it as a self join. See, join on the same table itself, we call it as a self join. Okay, so meaning, so when you will use the self join, so in which scenario you will go with the self join. Okay, see, you may go with them. Okay, my table is having this data. See, now I'm trying to look the employee information along with manager information. See, employee, everybody, CEO is also part of the same employee table. CEO information also, we are maintaining into the same employee table. A manager, clerk, everybody will be present in this employee table. If you are the manager, if you are my boss, if you are if you are working under me also, I don't care. Everybody information will be present in this employee table. Okay. Now, if you want to retrieve the employee information along with the manager information. See, this is my employee information. Now I need my manager details like a manager ID. The Smith manager is 7902. Now, who is this 7902? You need to search in this same table. 7902 is in this place, Ford. So Ford is belonging to which employee? So is working under whom? 7566. Who is the 7566? 7566 is John's. So John's manager is 7839 is the king. Okay, you need to display the manager employee information along with manager information. See, what is your information? What is your manager name? What is your manager joining it? What is your manager salary? So if you want to display these type of information, so you don't have option to write with any other giants here. You need to use to fetch the employee information one time, to fetch the manager information also using the same table. See now simply I'm copying this employee E as a table name and provided alias name for this. And EMP M is the manager table. So now I'm mentioning, like I say, two things here. Two things here, sorry. See here, I provided the alias name here, EMP. Now I'm trying to retrieve the data, EMP dot star. It gives the error because the system does not know the details, the thing clearly. What are the thing you mentioned alias name? Now the system for that particular query, it treat like as a E is the table, M is the table for this, not your EMP table. Now you mentioned this, you are getting the data now, right? See the self join. See, if you want to fetch manager information for the employees, right? So first you need to take the employee of manager ID equals to employee of manager ID equals to manager table of employee ID. See, this is the table is acting like two stages, two things. One stage it is acting like as an employee table. In one stage it acting like as a manager table. So now you are looking employee of manager ID equals to manager table of employee ID. Now you will get all the information. If you use the star in this case, see 7902, who is the boss for 7902? 7566 is the boss, right? Who is 7566? Jones. So the Jones information is displaying in this place. You can verify it. You can take another employee, Scott. Scott manager is 7566. I am displaying the Jones. Okay. You can take anything. You can verify it. See, 7902 for Smith, the 100 employees working under 7902. So who is 7902? 7902 is the Ford. See, you can see 7902 information are getting this. This is the advantage of the self-join. When you, in which scenario you will use the self-join. So where we need to use the same table itself to put the join, that we can call it as a self-join. In which scenario you don't have like, you may not get that things like very clearly on that particular times. Definitely everybody will use this, try to explain about this employee table example. And see, some people will get confused with what is equijoin and what is not non-equijoin. See, equijoin in the sense, it may be inner join, outer join, everything will be, see, wherever you are writing with equal operator, where e name equal to, see, if you mention like simply E dot manager ID equals to M dot employee number. This is the equijoin. So this self join, you can call it as equijoin also because you are using the equal conditions. We are comparing with equal conditions. If you are using other than this, equal to, greater than, less than, is other logical operators to compare. This we can call it as a non-equijoin. Non-equijoin, not equal to, greater than, less than, other than, equal, wherever you are using like between this type of conditions, right? This we can call it as a non-equijoins. We don't have any more joins other than this. Okay, this is about the joins and interview questions. See, sometimes, see if you use like the tables. Okay, this is about the joins. We'll see if it require any other things in the next classes. Okay, see now we're done with the join related things. Okay, see now I need to give the one more interview question. So what is subquery and what is correlated subquery and the differences of each other? See the subquery. See these are my tables I have in my current schema. Now I'm going to work with this particular table. See, so I'm going to work on the particular table like as a product table. Okay, see this product table is having the product ID, product name, description, standard cost, and list price. So standard cost, like what is the price he is getting, what is the selling price that you are going to maintain in this column, and category, and which category is this product belonging to. Okay, so you may have the multiple categories, so that you are going to maintain in this particular table. Now I need the requirement, I have the requirement like simply display the cheapest product information from the product table. Cheapest information from the product table. So for that, so what is the cheapest price we are selling, that you need to find first. And you need to use the function like this. Select minimum of least price from list price, not the least. This is the list price. So list price in the sense selling price. See, minimum of list price from the product table. So then you will get some value like 100 or 200 kind. Okay. Then you can look the select star from products table where list price equals to this minimum price. See if you get like the value like select min of price equal to 10. If you want to retrieve that product information, simply you can go with select star from or select the column names where list price equals to 10. So you need to write in this way. You need to write the two queries, and first you need to write one query to get the minimum price, and use that value inside this where class. You will get the required results for you. Okay. See, this is the why you were writing it. See, you are hard coding, you are taking the results of one query and you are hard coding that into the another query. Right. Instead of writing these two different queries, I can make it as a single query. Simply, I can make it as a simple. So instead of this column value, instead of hard coding of this value, you can pass it as a query to this value. Query. Instead of this column value, you can pass some query to this value. This we can call it as a subquery. This we can call it as a subquery. See, whereas in this case, first the subquery will execute, the nested query will execute first. Based on these results, the outer query will execute. See, here what you did, first you did this query, executed this query, and you taken these results and passed in this, and you run this. The same functionality can work in this way. First, this query will execute, it get the results for this, and it will display the outer query results for that based on. This is one This is one thing. What is subquery in the sense? What is correlated subquery? we have two types of subqueries. So what is a simple subquery, and another thing is the correlated subquery. See, it is opposite to the subquery. It look like as the same as a subquery, but it is a it works as a different opposite. Okay, as opposite to a regular subquery, where the outer query depends on a value provided by the inner query. By the inner query. See, it always the outer query will depend to the inner query in correlated subquery. In correlated sub, there is no dependency here. See, there is no link for outer query. See, first it is the inner query will running as a independently. Based on these results, the outer query will executing it. Okay. So whereas coming to the correlated subquery, it always depend to the outer query to the inner query. See, simply see here. See, a correlated subquery is one where the inner query depends on a values provided by the outer query. See, it always depends outer query to the inner query. This means this means that inner correlated subquery, the inner query is executed repeatedly once for each row for the outer query results. See, if the outer query is having 10 rows, see, treat like a select star from EMP. You may that table is having like 10 rows. So if you are mentioning any condition inside the where class as a nested query, or if we are comparing with this inner query, so the inner query will execute 10 times, whereas in this case, it execute only one time, whereas in this correlated subquery, it will execute 10 times of the nested query. Okay, see, I will show some example here. Simply see here, I written some example like here. Write a query to find out all the products whose least price is above the average from their category. See, go with the other example simply. Take this employee table. See, this employee table is having the information. Now I need to retrieve which department is having the less salary. See, try to retrieve. So who is getting a greater than average salary of employees? See, I need to retrieve the employee information whose salary is greater than the average salary, whose salary is greater than the average salary. So for this, you need to do first select average salary of EMP. So you will take this output and you will pull the information simply where salary greater than salary greater than. So 1738.15. So these people are getting the average salary greater than the average salary. So you can pass it instead of this hard coding of the value, simply you can pass it this query, which query you use to find the average salary. You can make it as here simply. This is called like a subquery, right? See, now you are getting the average salary for all the departments. Now I'm looking like, so which employee is belonging to, say, treat like I say, we have three departments like 10, 20, 30. So I need to look the average, the employee belonging of their own department. Got it, right? See, employees having like 14 employees we have. Now I need to see the average of 10th departments, and I need to look who is getting the greater than of this particular. Okay, so we have this three employee information. See, if I see the average of this particular three members, I will get the average like 5,000 plus 2,000 plus three, like we get like almost 9,000 divided by three, almost 2 9 something you will get. See, or you can simply mention like a where DPT number equals to 10. So you will get like a 2387. See, now I need to look the values for the 10th department. So on the 10th department, 2387. 2387 is the default, the average salary for that 10th department. I need to look the value. So which employee is having a, one second. So now I need to display. So employees whose salary is greater than average salary of their own department, their own department. So if you are belonging to the 10th, I need to look only for the 10th department employees, not with the all employees. So in such scenario, the same query, I'm going to make it as a, see now see, if you want to retrieve the 10th one, so you need to use like a 10th where DPT number equals to 10. So if you want to retrieve 20th department, so you need to write like this, right? There is no relation to the inner query to the outer query here, right? So you are looking like a, so where DPT number equals to 20, right? So the same, instead of this value, see, this is like a outer query O. So this is like a inner query I. Okay, I dot department number equals to O dot department number. O dot DPT. See, it always check the value. See, while it displays this value first, while displaying this, it always check the particular employee's salary is greater than this part. See, this query will like work like this. Select average salary from EMP, where I dot department number equals to, this value can come to the outer query. This value will get the, whatever the record you are going to compare, the first record or second record, third record, it take the value of a department number and display to this and it compare this. Now you won't get much records here. See, for 10th department, you will get only this. You can compare. What is the average? 2387 is your average salary. And you can compare the values. 2387 is greater than of these two employees or not. 2387, 2450, 5000. You are getting these two. If you haven't mentioned this particular condition, you won't get that particular results. See, you are getting this, maybe the average value is less than that particular value, you are getting that. Okay. So you need to compare these values. This is about subquery and correlated subquery. The difference here, you already observed, the difference is here, the first subquery will execute in the normal subquery. I'm saying the normal subquery, the first subquery will execute based on the subquery results, the outer query will execute. Subquery here, it is executing only one time. Whereas in the correlated subquery, first outer query will execute. Based on the outer query, the inner query will execute. If you have 10 rows, the inner query will execute 10 times. So the subquery, normal subquery will faster than the correlated subquery because it's comparing like it running like multiple times. However, if you are running in the multiple times, definitely it will take some time to get execute that. This is about the differences things. And we'll see some other things. Difference between, what is difference between replace and translate function? See, replace function, replace the values with string base. But translate function will replace the values character base. See, the syntax is look like this: replace string, search string, and replace string. Whereas in the translate, okay, so go with the this replace function once. See, now I'm passing as a string as a computer, and I'm going to replace OM with AB. See, now see, wherever I'm getting OM, it is replacing with AB. Now, whereas in this case, if I mention like OA, CO, AM, see, there is no continuous string OM. It won't replace anything here because you are replacing whole string at a time. The entire string, if you found anywhere in this particular string, I'm going to replace with that with OM with AB. If you haven't found that entire string, I'm not performing anything in this. Whereas in this translate, it can be replaced. Wherever I'm getting O, I'm going to replace with A. Wherever I'm getting M, I'm going to replace with B. You can check these all things. Now the value is different from this to this. Okay, this is about this translate and replace. This is one another minor important, not like bigger important. It's a small important